What is linear regression in machine learning? Imagine trying to predict how much a house will sell for based on its size, or estimating a person's weight from their height. These are classic examples of what linear regression can do. Linear regression is a type of supervised machine learning algorithm. It helps us find a straight line that best fits the data points we have. In machine learning, supervised means the model learns from labeled data where we already know the answers. In the case of linear regression, the goal is to model the relationship between a dependent variable and one or more independent variables. The dependent variable is what we want to predict, like house prices or test scores. The independent variables are the inputs, like house size or hours studied. The core idea is that the dependent variable changes at a steady rate as the independent variables change. This is called a linear relationship. The model tries to find the best-fitting straight line, called the regression line, that minimizes the difference between the actual data points and the line itself. This line can be described with a simple equation. Y equals m times x plus c here. Y is the outcome we want to predict. Is the input, m is the slope showing how much y changes when changes, and c is the intercept, which is the value of y when is 0. Once the line is found, it can be used to predict new outcomes based on new input data. For example, if you know a house's size, the model can estimate its price. This makes linear regression a useful tool in many fields like finance, healthcare, marketing, and social sciences. In machine learning, linear regression is a basic example of a regression algorithm. It falls under the broader category of regression algorithms, which predict continuous outcomes. It also fits within the machine learning paradigm of supervised learning because it learns from labeled data. Understanding linear regression helps us grasp more advanced models like logistic regression and neural networks, which build on its principles. Although it might seem simple, it forms the foundation for many predictive analytics tasks. In practical AI tools like ChatGPT, DALL-E, or Midjourney, linear regression might not be used directly for generating text or images. But it plays a key role behind the scenes in data analysis and prediction tasks that improve these systems. For example, productivity plugins may use linear regression to forecast user behavior or resource needs based on past data. It is important to use linear regression ethically. If the data used to train the model is biased, the predictions can also be unfair or inaccurate. Transparency about how the model works helps users trust AI systems and understand their limits. To sum up, linear regression is a straightforward supervised learning algorithm that models the relationship between variables with a straight line. It is a stepping stone to more complex AI models and has many applications in data-driven decision-making and AI-powered tools.